Alright, in this video here we're going to talk about the half angle formulas for sine, cosine, and tangent. But before we get to the half angle formulas, we're going to talk about the formulas for lowering powers. So these are used sometimes in calculus when you're doing integral problems, especially when you're doing integral problems. Like if you have a sine squared or a cosine squared or a tangent squared in your integral in the problem you're trying to do, and you don't have rules to work with that, but if you can reduce it to like a trig function to the first power, you're able to actually proceed and go through with the problem. So that's why we call these formulas for lowering powers. In case of sine squared into a cosine to the first power, right? A cosine squared into a cosine to the first power. A tangent squared into cosine to the first power. And a lot of times in calculus, if you're able to do that, you are then able to use the rules of calculus to proceed and do your problem. All right, so these formulas may come up again if you proceed on to calculus 2. You're likely to see these in one or two problems, not all the time, but like in one or two problems in calculus 2, this stuff is going to come up. All right. Also, these formulas, if you watch the other video that I just did on the double angle formulas, the double angle formulas for cosine of 2x equals, there were three different formulas there. These two formulas up here come directly from those double angle formulas. Like notice they both involve a cosine of 2x. If you rearrange those double angle formulas and solve one of them for sine squared of x, you get this. If you solve the other one for cosine squared of x, you're going to get this formula over here. All right, so these come directly from those double angle formulas for cosine. Right, so sine squared of x equals 1 minus cosine of 2x over 2. Right, cosine squared of x equals 1 plus cosine of 2x over 2. Right, and then tangent squared of x, well remember, tangent is sine over cosine. Right, so if I do the sine squared of x, this, over the cosine squared of x, that, and I simplify it, I get the formula for tangent squared of x, which is 1 minus cosine 2x, right, this one up here from sine, over 1 plus cosine 2x, which is the one up here from the cosine. Right, so the tangent formula comes directly from doing sine squared over cosine squared and then simplifying. That's exactly what you're going to end up with. All right, so a lot of these trigonometric formulas are related to each other. Like I said, the sine squared and the cosine squared, they come just from rearranging the double angle formula for cosine. Right, that's all it really is. It's just that same formula rearranged a little bit. So if you really understand these trigonometric formulas and where they all come from, like when you see them, there's like so many different formulas. But if you see how they're all interrelated, you kind of see those connections and you don't have to memorize every single different formula. It's just, if I know one of them, all right, I can rearrange it and change it into this one if I need to use this one. Right, so that's one of the advantages of really understanding the formulas and how they interact with each other and how one of them comes from the other. All right, so the half angle formulas. Now, the half angle formulas come directly from the formulas up here, these formulas for lowering powers, right? Sine of u over 2 equals plus or minus the square root of cosine of u all over 2. Right, well notice that this 1 minus cosine u over 2, that looks a lot like what this is up here, right? It's 1 minus cosine 2x over 2, and over here I had sine squared of x. Right, so all that happened from this formula here to this one down here, instead of the 2x here, I made that just a 1u, and therefore the 1x became a 1/2 u, or a u over 2. And then if you take the square root on both sides of the equations, right, you get sine of u over 2 equals plus or minus, because remember when you do the square root on both sides you have to put the plus or minus in front, so you get plus or minus the square root of 1 minus cosine u over 2. Again, it comes directly from this formula up here for lowering powers. Right, cosine of u over 2 comes directly from the formula for cosine squared of x in the same way. Right, notice, well we have cosine of u over 2 equals plus or minus the square root of 1 plus cosine of u all over 2. Well, over here we had that 1 plus cosine 2x. So I replaced the u, the u for the 2x, and so the 1x here became the 1/2 u, or the u over 2. And then once again, I do the square root on both sides of this equation, and that gives me this formula right here. Right, so those two, again, come directly from the formulas up above for the lowering power formulas. Right, and then tangent of u over 2, there's two formulas for tangent. It's 1 minus cosine of u over sine of u, or sine of u over 1 plus cosine of u. I thought that looked wrong when I was looking at it. Right, sine u over 1 plus cosine of u. Right, and this one also comes from these formulas up here. I'll let you try to figure out how that works if you're interested in trying to do some extra work and trying to figure some stuff out. Try to show how these formulas here come from maybe some of the other ones that we had up above. And if you work on it, you should be able to figure out how that works. All right. Now, for these ones, the sine of u over 2 and the cosine of u over 2 that has that plus or minus in front, we choose the positive or the negative depending on the quadrant of the u over 2, right? So, if u over 2 is in the second quadrant, it's going to have a negative x, so the cosine is going to be negative, but it's going to be a positive y, so the sine is going to be positive, right? So it goes back to the definitions of the sine and cosine in terms of the x and y coordinates on the unit circle, and in which quadrant the x is positive and the y is negative, or whatever it happens to be, right? So when you're doing these half-angle formulas for sine and cosine, you have to pay attention to that. What quadrant am I in? And is sine supposed to be positive or negative there? Is cosine supposed to be positive or negative in that particular quadrant? All right, so those are a whole bunch more trig formulas, and if you watch some of the videos I did recently, we talked about addition and subtraction formulas, we talked about the double angle formulas, now we have the formulas for lowering powers, the half angle formulas. As I've said before, there are a ton of formulas involved with the trigonometric functions, but a lot of them are interrelated, as I showed you with some of these here. Like they're just like, oh, if I know this formula, if I rearrange it a little bit, it gives me this other formula. If I rearrange that one a little bit, it gives me this other formula. All right, so if you see how they're connected to each other, it helps in the remembering of the actual formulas themselves. All right, so I'm going to pause the recording here and delete all these formulas. I'm going to erase all these formulas, and then I'm going to put up an example where we'll use, I don't know which one or two of these half-angle formulas to actually solve a problem. All right, the example we're going to do here, we're asked to find tangent of u over 2 if we know that sine of u equals 2/5 and u is in quadrant 2. All right, so I have up here, remember there's two formulas that were just up here, they're like the ones that were down at the bottom. Two formulas for tangent u over 2, but they both involve knowing sine of u and cosine of u. Well, I know that the sine of u is 2/5, but I don't know the cosine of u, right? So we can use either one of those formulas, and after we figure out what cosine of u is, we'll maybe take a look again at those formulas and try to decide which one is more advantageous for us to use, or if it just doesn't matter and we'll just use either one and it makes no difference. So I know sine of u equals 2/5, but to use these formulas, I also need to know cosine of u. So, and if you watch the video that I did on, I think it was the double angle formulas, we had to do something similar in the example there. Sine squared of u plus cosine squared of u equals 1. Right, so if I know sine of u equals 2/5, and I know this identity, right, this Pythagorean identity, which in a lot of the videos I've done, it keeps coming up. It's a really important one to know. If I ever know the sine of an angle and I need to know cosine, or if I know cosine and I need to find out sine, I can use this formula to figure it out. Right, so sine of u is 2/5. Right, so sine squared of u means 2/5 squared. Right, remember sine squared of u. Right, what that means is sine of u squared, right? We just write it in a shorthand way like this, so we don't have to put parentheses around everything. We just put that second power on the sine function. But when you see that sine squared, this is what it means. It means the sine of u, whatever that value is, squared. So if sine of u is 2/5, sine squared u is 2/5 squared, right? I put in the value for sine of u, and then I'm going to square that. Right, so 2/5 squared plus cosine squared of u equals 1. 2/5 squared, remember when you square a fraction, you square the numerator and denominator, so that's going to be 4/25 plus cosine squared of u equals, now instead of 1, I'm going to write that as 25/25, right? Because I know that I'm going to have to subtract this 4/5 to the other side, sorry, this 4/25 to the other side, and when I do that, in order to subtract it, my two numbers are going to have common denominators, so let me just go ahead and write that 1 as 25/25 right now, and then when I subtract the 4/25, what I end up with is cosine squared of u equals 25 minus 4 is going to be 21/25. All right, so that's what cosine squared is equal to. Now to find cosine of u, I need to do the square root on both sides. Right, so I end up with cosine u equals plus or minus the square root of 21 over 5. Right, so a couple things there with that final result. Remember, when I use the square root to solve an equation of something squared or to cancel out a second power, when I do the square root on the other side of the equation, I need to put that plus or minus in front. Just like when we solved equations, x squared equals 4, I did the square root on both sides, I get x equals positive and negative 2. Same deal here, right? Those rules of algebra don't change just because we're dealing with a trigonometric function this time. Still, when I do the square root on both sides, I have to put the plus or minus in front. Right. The other thing, when I do the square root of this fraction, I can't do the square root of 21, right? So the 21 stays under the square root. I can do the square root of 25, which equals 5, and now that 5 is no longer underneath the square root. Right? So it's plus or minus the square root of 21 over 5. All right, now the question is, well, is it the positive or is it the negative? Which one of those do I choose for cosine of u? And it comes back to u is in quadrant 2, right? They're telling us that the angle u is in quadrant 2, which means, I don't know exactly where that's going to be, but it's going to be over here somewhere. There's our angle u. So remember, the terminal point there, well, the cosine gives me my x-coordinate, and the sine gives me my y-coordinate. Right? So the sine is a positive 2/5, because if I'm in the second quadrant, I have a positive y-coordinate. Right? That's why the sine was a positive number. Cosine gives me my x-coordinate. Right? So if I'm in the second quadrant, I'm going to have a negative x-coordinate, which means I need to choose the negative answer here for the cosine of u. Cosine of u is going to be negative square root of 21 over 5. Right? So I'm looking for where I can write that down. I'm going to erase some of this stuff here so I can put this up. So I know that sine of u equals positive 2/5, and now I know that cosine of u equals negative root 21 over 5. All right, so again, when you're doing this, when you're using that Pythagorean identity, sine squared plus cosine squared equals 1, when you're using that to solve for either sine or cosine, you go through the same basic algebraic steps to solve it. Make sure when you do that square root, you put the plus or minus in front, and then you have to think about, well, where is this angle? Which quadrant is it in? If it's in quadrant 2, that tells me whether cosine is positive or negative, whether sine is positive or negative. In quadrant 2, cosine, the x-coordinate is negative, and sine, the y-coordinate, is positive. Right? If this had been in a different quadrant, I might have chosen the positive instead of the negative. Right? It all depends on which quadrant I'm in. All right, but that gives me my sine of u and my cosine of u, and now that I have those numbers, I can plug them into either one of these formulas to find tangent of u over 2, which is really what this problem was asking us to do. Now, would one of these formulas be better than the other? The answer is yes, right? Since my cosine involves that square root, I'm not going to use the formula that has the cosine in the denominator, because if I put negative root 21 over 5 in here, I'm putting a square root in the denominator, and that's going to create more work for me, because then I'm going to have to rationalize the denominator to get rid of that square root. All right, so let me not use this formula this time. Let me use this formula here, where the cosine is in the numerator, and I don't care if there's a square root in the numerator, but then sine of u, which is a 2/5, that's not going to give me any square roots in the denominator that I would then have to rationalize in order to simplify my answer. All right, so you can use either one. It's not wrong to use this formula here to figure this out. It's just that if you do that, you're going to have to do those extra steps of rationalizing the denominator, which if I can help it, I'm not going to do those extra steps. All right, so call it taking the lazy man's way out. I call it taking the smart way out. Trying to set up less work for myself. All right, so tangent of u over 2 is going to be 1 minus cosine of u, which is negative root 21 over 5, over sine of u, which is 2 over 5. All right, now what we have here is a compound fraction, which we are not supposed to leave, answers as compound fractions with fractions within a fraction. I did a video way back when about how to simplify compound fractions. Both of my fractions, my smaller fractions here, have a denominator of 5. So if I just multiply the numerator and denominator, I multiply this whole thing by 5 over 5. When I distribute that 5 times 1 is going to equal 5. When I do 5 times, these double negatives here is going to be a plus, root 21 over 5. The 5 is going to cancel out that denominator, and it's just going to be 5 plus the square root of 21 in my numerator. And when I multiply the 5 times my denominator, it's going to cancel out that 5, which just leaves me with a 2 in the denominator. So tangent of u over 2 is going to equal 5 plus square root of 21 over 2. Right? So a lot of stuff goes into play when you're doing a problem like this. A lot of real technical little algebraic things, technical trigonometric things of, which quadrant am I in? So is sine or cosine positive or negative? Knowing the formula, simplifying those compound fractions, a lot of little things you have to be able to do correctly in order to do the problem right. And you'll find that as you go to higher levels of mathematics, it all builds up, right? So you'll get into calculus 2, and you'll have a problem where you have to do all that same stuff correctly, but then also do all the stuff you're learning in calculus 2 as well in order to do the problem right. So don't forget all the things you learned in algebra and trigonometry as you move on. They are all important as you move forward and learn new things.